My name is Lee Ma, and I'm a professor of statistics and data science at the University of Chicago. I consider myself primarily a data modeler. I enjoy thinking about how data arise in various domains and representing these data-generative mechanisms through probabilistic and statistical language. Every model, however large or flexible, inevitably relies on assumptions. Reliable scientific conclusions and sound decision-making depend critically on incorporating assumptions that properly account for the study context and experiment design when building and evaluating models. I think making appropriate assumptions and testing them is key to balancing the generalizability, scalability, interpretability, and robustness of models. How to achieve this balance when models become massive and highly flexible is one of the central questions I aim to address in my research. Over the years, I have studied several popular classes of statistical models. Many of them are generative, including tree and partition-based models, ensemble models, mixture models, and other latent variable and hierarchical models. I have explored their properties, developed new algorithms, and tailored these models and algorithms to real-world applications, particularly in biomedical research. The recent explosion of computer-generated data driven by the advances in generative AI presents both new challenges and opportunities. A recent focus of my group is on design-aware assessment of generative models. After all, a synthetic dataset should be evaluated within the context of the study it is intended to emulate. For example, in a microbiome study, a biomedical researcher who employs a generative model to synthesize microbial compositions must assess the model in the context of its biological and study-specific constraints, rather than simply comparing synthetic and real data using generic distance metrics. Ultimately, I hope my work will help broaden the applicability of modern generative models and other statistical models to a wider range of scientific investigations and societal decision-making contexts, where sound data analysis directly impacts the well-being of individuals and communities.